Welcome to our tutorial on building a face recognition-based access control system. In this video, we'll guide you through the entire process, from setting up your environment to deploying a fully functional application. Let's start by discussing the project requirements and tools we'll be using. For this project, we will leverage OpenCV, a powerful computer vision library, and the DLib library for face detection and recognition. We'll also use Java as our programming language. Additionally, we require a camera for real-time face recognition. Ensure you have the following prerequisites installed on your machine: JDK, OpenCV, and DLib. Let's go ahead and set up our development environment. First, install the OpenCV library. If you're using Maven, add the following dependency to your pom.xml file. Next, download the DLib library. Since DLib is primarily a C++ library, we'll create a Java native interface, JNI, wrapper around it. Follow the instructions on the DLib website to build the library for your operating system. Once you have installed both libraries, let's create a basic structure for our project. Create a new Java project in your IDE and set up the following package structure: com.face_recognition.access_control. Inside this package, create a class named main.java. This will contain the main logic for our application. Let's begin by including the necessary imports. Make sure to load the OpenCV native library early in our main method. This allows us to utilize the OpenCV functions in our application. Now, let's implement a method to capture video from the webcam. This will serve as our input for face recognition. We will use the video capture class provided by OpenCV. Inside this method, we instantiate the video capture object with the index 0, which usually corresponds to the default camera. We then enter a loop to continuously capture frames from the camera. Next, we need to implement face detection. We'll use HAR cascades to detect faces in our captured frames. Download the HAR cascade.xml file from the OpenCV GitHub repository and place it in your project's resources folder. Here, we load the HAR cascade classifier in the detect face method. We then use it to perform multi-scale detection, allowing our application to detect faces of different sizes. After detecting faces, you can display rectangles around them in the video feed. Let's add this functionality next. This code snippet will draw a green rectangle around any detected faces in the video frame. Let's consolidate everything we've written so far inside our main method. We will call our camera and detection methods to ensure the camera feed is working correctly with face detection. Now, to display the captured frame with detected faces, we'll use imshow from OpenCV. This function allows us to create a window to visualize the video feed. In this code, we call higua.imshow to display the processed frame and control the loop with wait key, which waits for 30 milliseconds before moving to the next iteration. Next, we need to implement face recognition features. Start by creating a new class called Face Recognizer within the same package. This class will handle the face encoding and recognition. In this class, we'll create an instance of a face recognizer using the local binary patterns histogram (LBPH) method, which is suitable for this type of application. Now, you'll need methods to train the model using images of known individuals. Create a method called trainModel that accepts a list of image paths and their respective labels. This method reads images from the provided paths and converts them to grayscale, then trains the recognizer using the collected images and labels. Next, let's implement the recognition logic in our detect face method. We'll modify it to classify detected faces using the face recognizer. In this updated code snippet, after extracting the face region, we use the predict method to classify it against our train model. If the recognized face matches a person in our database, we can grant access. For this example, we'll simply print a message in the console. In a real application, this is where you might trigger an electric lock or notify a security system. Let's discuss how to handle adding new users to our database. We'll create a method called addUser that captures an image and adds it to our training set. In this method, we utilize a webcam capture method and save the captured image as a JPEG file for subsequent training. Next, we will write code to connect this functionality with our user interface. We will utilize Swing for creating a simple GUI for our application. This class creates a simple JFrame with an Add User button, where clicking this button will invoke the Add User function. Now, let's make our system more robust by adding error handling, especially while capturing images and during face detection. Implementing error handling and exceptions will help to troubleshoot and maintain the stability of your system as you integrate additional features. Finally, let's recap what we have accomplished in this tutorial. We set up a Java application integrating OpenCV for face detection and recognition, built an interface for user management, and implemented error handling. To continue improving this project, consider adding features like database integration for user management or improving detection accuracy using more sophisticated algorithms. Don't forget to share your experience or ask your questions in the comments below. If you enjoyed this video, please like and subscribe for more tutorials on Java and related technologies.